Hello dear students, the program is B.Sc, subject Mathematics, paper 1, third semester, unit 1, Mathematic Logic. The topics which we are going to discuss in this session is Tautology, Contradiction and Logical Equivalence. This is Srimati Ashwini S, Assistant Professor of Mathematics. Now let's see the definition of tautology. The definition says a compound proposition which is true for all possible truth values of its components is called a tautology, which means to say how many ever tables we write, whatever the formulas we are taking, for all the possible different combinations, we are going to get the final column as t values only. When all the entries in the last column becomes t, such a compound proposition will be known as tautology. It is also known as logically truth. The next definition which we are going to see is contradiction. A compound proposition which is false for all possible truth values of its components is called contradiction. So in other words, how much ever columns we have, we will be using the symbols and writing the truth table. The last column, all the entries should be taken as capital F. So when the last column entries becomes capital F, they are known as contradiction. It is also known as absurdity. Now let's consider an example. The problem says, prove that P if and only if Q, if and only if negation P or Q and negation Q or P is a tautology. So we have to construct the table based on the given propositions using the connectives, and finally we have to check in the last column if all the entries are going to be capital T. So first of all, let's see how many letters are given here. 2 letters are given, so which means to say 2 propositions are given, P and Q. So since the expression is very big, what we will be doing it, we will be taking the first row as numbers, the second row as the propositions, followed by the 4 rows of the different values. Now the first column I write it as 1, below that I'll be writing your first proposition P. Second, I'll be writing it as 2. Below that, I'll be writing it as Q. So the 2 propositions are P, Q. Now since there are 2 propositions, as we all have studied in the previous session, we will be having 4 combinations. For P, the first 2 values will be capital T followed by 2 capital F values. When it comes to Q, first one is capital T, second one is capital 4, third F. Third one will be capital T followed by capital F. Now, when you look into the problem, you know we have negation P as well as negation Q. So what we will do is, we will write the third column as negation P in symbol, fourth column as negation Q in symbol. Now, how do we obtain this negation P? We have to go to the first column. So whenever we have this P value, you know there are 4 different values here. We have to write its negation. That is, for example, when I take the first value, I have capital T. So negation of capital T is capital F. The second value is again capital T. So its negation becomes capital F. The third value is capital F. So its negation is capital T. The fourth value is capital F. So its negation is capital T. Now this is our negation P in the third column. Next, what you have to do is, we will be considering the fourth column. In the fourth column, we have negation Q. So we have to consider the second column and write its opposite sign. That is, if you have capital T, then it becomes capital F. That is your first value. Now the second value in the second column is capital F. So its negation becomes T. The third value is capital T. So its negation becomes capital F. The fourth value is capital F. So it is capital T. Now let's see the problem. The first logical connective given in a small bracket is P if and only if Q. Now you know this is biconditional. This biconditional is true only when both P and Q are true and both P and Q are false. Now when I look into the first column and the second column, the first element both are T. So obviously in the fifth column, the first element will be capital T. Again, when I take the last combination value, both of them are F. So, you know, when I take biconditional condition here, then it is going to be T. So the first row and the last row will have T. The second and the third one will be capital F. Next, let's move on to the next small bracket. So that says negation P or Q. Now negation P is there in the third column. Q is there in the second column. I will be using the connective or. As I've already told you, when we use this OR symbol, if either one of them is capital T, then our negation P or Q will be capital T. If both of them are F, then obviously our answer is going to be capital F. Now let me see which combination is that. In the first combination, you know, one is F, another one is T, so obviously it is T. So in the second combination, both are capital F, so our answer is F. In the third row, both are T, so obviously it is capital T. In the fourth combination also, one is T and other is F. If any one of them is T, you know, negation P or Q is going to be T, so we are going to write it as T. Now let's check the next bracket, with small bracket, which is given as negation Q or P. Now negation Q values in column number 4, negation P values in column number P. We are going to use the same concept as we have done it in column 6. So if both the values are capital F, then it is going to be F. In other cases, it is going to be 3. Now when I look into column number 4 and column number 1, you can see the third combination has both F. So that is the reason the third value in column 7 is F. In all other cases, it is T. So we have finished all the small values here. Now we have to connect them. Now let me take the big square bracket which is there on the other side of the logical connective. So negation P or Q, negation Q or P is connected by the logical connectivity and. You know, negation P or Q is in column number 6. So what I'll do in column number 8 is, first I'll be writing it as column number 6. The logical symbol used there is and negation Q or P is in column number 7. So to simplify the problem, I'll be writing it as column 6 and column 7. So now what we have to do is, we will be using the AND condition for column 6 and column 7. Now what is this AND condition? This will be true only when both the first proposition and the second proposition are capital T. In all other cases, it is going to be capital F. Now let me concentrate on column number 6, column number 7. Let us take the first entries in both the columns. The first entries in both the columns are capital T. And since you know, if both are capital T, when we use this AND condition, it is going to be capital T. Now when I come to the second level combination, one is capital F, one is capital T. So obviously your answer is capital F. When I come to the third combination, the first one is capital T in column number 6. Second one is capital F in column number 7. So when I use this AND condition, the answer is going to be capital F. Now let's go to the last combination. The last combination has capital T and capital T in both the places. When I use this AND symbol there, your answer is going to be capital T. So we almost finished 80% of the problem. Now when you look into the question, the first one is written in a bracket, the second one is written in a bracket. Both the brackets are connected by a logical connectivity if and only if. Now this double implication Q is there in column number 5. So in column number 9, below that I'll be writing it as 5. And the next bigger bracket is taken as column number 8, which we have already solved. Now, these two compound propositions are connected by if and only if symbol. Now, next what we have to do is, we have to concentrate on column number 5, column number 8. And we have to consider each combinations with the logical connectivity if and only if. Now, since as we have already studied, this if and only if is applicable only when both of them are T or both of them are F. Now let me look into column number 5 and 8. The first entries in both are capital T. So double implication gives me capital T. The second values gives me both are capital F, and you know its answer going to be T. The third value was both are capital F, so our answer is capital T. The last combination, both are capital T, so obviously our answer is capital T. So what have you observed here is, in column number 9, we have 4 entries and all the 4 entries are capital T. I hope you have understood this. Now let's see what happens in the next step. Now here it says column 9 contains all the truth values as T. Hence, the given proposition is tautology. I've told you if the last entry contains all the values as T, then we say as tautology. Hence, the given proposition is a tautology. Now let us see the definition of logical equivalence. Two compound statements of the same components are said to be logically equivalent if they have same truth values for all combinations of truth values of their components. To say it in a simple way, there will be two different propositions, compound propositions, one on the left hand side, one on the right hand side. They will be connected by this symbol. Okay, so what we have to do is we have to solve the LHS part separately, we have to solve the RHS part separately and check if all the entries in the LHS value and all the entries in the RHS values are equal or same. When both are same, then we say that they are logically equivalent. Now let us consider an example here. It says negation of P if and only if Q is logically equivalent. You can see there is that equal sign, 3 equal signs are there, 3 dashes are there. So that is read as logically equivalent, and the other part of that is P and negation Q or negation P and Q. So the left hand side part is negation of P imply if and only if Q. The right hand side part has 2 connectives and those 2 are again connected by a connective. So the first one is P and negation Q. We have to solve it separately. And then we have negation P and Q. That also should be solved separately. And for both we have to use OR. And then check whether the left hand side part and the right hand side part comparisons gives me the same value. Now when we look into the problem, there are 2 propositions P and Q. So let us construct the truth table. So again your numbering is done so that your problem is simplified. The first column is P, the second column is Q. Now since there are 2 negations, third column is negation P, fourth column is negation Q. Now let me write the left hand side term which is inside the bracket. So that is P if and only if Q. And then we have to take negation of that. Now P if and only if Q is there in column number 5. So in the next column, I will be writing it as negation of column number 5. Now in the right hand side part, the first term is P and negation Q, which I have written it in column number 7. The second one which is there in the given bracket is negation P and Q, which I am writing it in column number 8. Now column number 7, column number 8 is again connected by a logical connectivity R, which I am writing it in column number 9. So there are totally 9 columns in this problem. After solving the problem, what we have to do is we will be checking column number 6 values with column number 9 values. If all the entries in column number 6 and all the entries in column number 9 gives us the same value, then we will say it is logically equivalent. Now let's discuss each point in detail. So the first column is P. So by now I think it should be clear for you all to write 2 T's and 2 F's, and when it comes to Q, 1 T, 1 F followed by 1 T, 1 F. Third column is negation P, so just the opposite of P you're writing it, the other part of this. And fourth column is negation Q, so you'll be writing the Q part in a other way. So the fifth one is P if and only if Q, so we have to check the first and 2 columns. Our condition is if both are true, it is true. If both are false, it is true, which we find in the first and the last combination. The second and third becomes F. So in the 6th column, what we are doing is we are writing negation of F. So the first value is capital T, so its answer becomes capital F. Next value is capital F, it becomes capital T. Next is capital F, so its negation is capital T. And then you have capital T, its negation is capital F. So column number 6, I have finished it. I have denoted that in a different color so that it becomes easier for us to compare it in the end. Next what I do is I take the right hand side part, the first one which is there in the bracket. It is P and negation Q. Now P is in the first column, negation Q is in the fourth column. So we will be using AND symbol condition for the first column and the fourth column. Our condition here is it will be true only when two propositions are true. That happens in the second combination only. So only in the second combination it is going to be true. In all other cases it is going to be capital F. Now column number 7 is done. Now let's go to the other bracket in the end, which is negation P and Q. Now this negation P is in third column, Q is there in the second column. Now the third column and second column will be compared using the symbol, and again here only when both are T, our answer is going to be capital T. In all other cases it is going to be capital F. So which is that combination? We find it in the third combination. So in the third combination it is going to be capital T. In all other cases it is going to be capital F. Now 7 and 8 is connected by the logical symbol OR. So what I'm going to do now is I'm going to write column number 7, column number 8 connected with the symbol OR. Now let us finish the problem by column number 7, column number 8 with the symbol OR. Whenever I say OR, you know, if any one of them is true, it is going to be true. If both of them are false, it is going to be false. So the first one and the last one has capital F value. So obviously its answer are going to be capital F. The second one and third one has at least one T value. So final answer is going to be capital number T. Now column number 9 is also represented in a different color. Now let's compare column number 6 and column number 9. The first values in column number 6 and 9 are capital F, which are same. In the second combination you have capital T and capital T. In the third combination you have T and T. In the fourth combination you have F. The last combination is capital F and capital F. So when you look into this, they are same. So we say all the truth values are same in column number 6 and column number 9. So when this condition happens, we say therefore the propositions are logically equivalent. Now next is laws of logic. So here what we are going to do is there are certain laws which we will be using in solving problems in the future classes. So here we will be considering 3 propositions and they are denoted by P, Q and R. Now here to simplify the laws, what we are going to do is wherever we have this tautology, we are going to represent it by capital T naught, and wherever we have to denote it as contradiction, we will be denoting it as capital F naught. Then the first law is called law of double negation. That is, negation of negation P gives me P itself. You all will be remembering that in matrices we have something known as A complement whole complement is equal to A, or to be in a simple words, you all have studied set theory in your middle school or high school. There you know A dash whole dash is A, isn't it? The same thing we are using it here. The second one is known as idempotent loss. Idempotent loss. So it is like when we take OR of two propositions, we get the same answer. When we take AND of two propositions of the same propositions, we are going to get P itself. The third one is identity loss. So here P or F naught, you know F naught is contradiction. So when we take P or F naught, we are going to get P itself. When we take P and T naught, we are going to get P itself. Next is inverse loss. P and negation P will become F naught. P or negation P will become T naught. Next is domination loss. So P or T naught. Here the dominate part is tautology. So final answer is going to be T naught. P and F naught will be logically equivalent to F naught. The next one is commutative loss. Now this is very clear for you all, which you have been studying it from high school, isn't it? So PRQ is logically equivalent to QRP. P and Q is equivalent to Q and P. This is like A union B is equal to B union A, and A intersection B is equal to B intersection A. Next one is known as absorption law. A proposition gets absorbed here. Now look into the first one. It says P or P and Q is logically equivalent to P. So here Q is getting absorbed by P. The next one says P and of P or Q is equivalent to P. Next is De Morgan's laws. This is nothing but D. You have studied A union B all dash is equal to A dash intersection B dash, and A intersection B whole dash is equal to A dash union B dash. Same way, negation of or will become and, negation of and will become or. So negation of P implies Q is logically equivalent to negation P and negation Q. Negation of P and Q is logically equivalent to negation P or negation Q. The next one is associative loss. This you are all familiar with union and intersection. So P or Q or R is equivalent to P or of Q or R. So similarly is for P and Q of and R is logically equivalent to P and of Q and R. Next is distributive loss. This again we all have looked into set theory. So P or of Q and R is logically equivalent to P or Q and P or R. Next one, P and of Q or R is logically equivalent to P and Q or P and R. Now the 11th one is very important because we will be using this in the future problems. They are known as laws of negation of conditional. So negation of P implies Q is always written as P and negation Q. So the main thing which you have to observe here is when I say negation of P implies Q, P remains as it is, negation of implies will become and negation of Q is negation Q itself. Now, P implies Q can also be written as negation P or Q. Negation P implies Q is logically equivalent to P or Q. Now next concept is converse, inverse and contrapositive. Now we always consider a conditional. Conditional in symbols is written as P implies Q. Now the converse of this will be Q implies P. Next what you have to do is we have to find the inverse. So to find the inverse, what we have to do is whatever the conditional we have written, we have to take negation of it. So inverse of P implies Q will become negation P implies negation Q. The last part is contrapositive. The contrapositive is nothing but negation of converse. So it will become negation Q implies negation P. Now this is the truth table. So you have P, Q, negation P, negation Q. P implies Q. By now you all will be knowing it. Next you have Q implies P. So when I have Q implies P, here you have to be careful. The first proposition in Q to be true. The second proposition in P should be false. Only then our answer is going to be false. In all other cases it is true. Now in the second column, if you see the third combination in second column and the third combination in the first column are T and F. So hence your answer is capital F. Next you have negation P and negation Q. So when first one is T, second one is F, we will be getting F, that is in the third combination. When I take negation Q implies negation P, the second combination is capital T and in the P negation P value it is F, so it becomes capital F. In all other cases it is T. Now let me finish the class by considering an example. Now we will be given a statement. For this we will be writing the converse, inverse and contrapositive. So the problem says write the converse, inverse and contrapositive for the proposition if two right angle triangles have equal hypothesis, then the triangles are congruent. So here what you have to do is, there are two propositions. The logical connectivity used is if then. So the two propositions are taken as P, the second proposition is taken as Q. So when you are writing P, what you have to do is we have to leave the word if. Leaving the word if, whatever the statement you have, that you will be writing it as P. So what is that statement we have here is two right angle triangles have equal hypothesis. So this is a first proposition denoted by P. Comma is there. Then you will be leaving this word then and then write the remaining part. What is the remaining part? The triangles are congruent. So P is two right angle triangles have equal hypothesis. Q is the triangles are congruent. If I have to write it in symbols, we will be writing the given proposition as P implies Q. Next, what you have to do is we have to find the converse, which is Q implies P. First, we have to write Q, then we have to write P. In between, you have to add if and then. So, you have to write it in symbols. It is going to be, if the triangles are congruent, then two right-angle triangles have equal hypothesis. The next was an inverse. As I've told you, inverse is negation P implies negation Q. So already we have proposition P, proposition Q. You have to add the word not at an appropriate place so that it gives us a meaningful sentence. So if I have to write it in words, it will become, if two right angle triangles do not have equal hypothesis, then the triangles are not congruent. The last part is contrapositive. This is negation Q implies negation P. Now if you have to write it in words, it says, if the triangles are not congruent, then the right angle triangles do not have equal hypothesis. So the references I've used is Introduction to Mathematical Logic by Elliot Mendelson. The publications is Wordsworth and Brooks in the year 1987. Thank you, dear students.